In this video, we're going to take a look at how to use Excel to generate the PDF and CDF values of a hypergeometric random variable. And the hypergeometric, it differs from the uh, negative binomial and the binomial and the geometric in the sense that the sampling is no longer independent, right? So it's a slightly different formula when you're doing things by hand. But in Excel, it's just a matter of knowing the function, right? So in this example, we're going to use a hypergeometric random variable where our entire population consists of 20 objects. We're going to sample 8 of them. So our big N is 20 and our little n is 8. And of the 20, only 4 of them represent what we would consider successes, right? And that's our little a. So the big N is 20, the little n is 8, and then the little a is 4, right? Now, if you think of these values, and if you apply the max and min functions that are in our formula for the sample space of a hypergeometric distribution, we can see that it is possible to have no successes, right? Because if only 4 of the 20 represent successes, then there's 16 ways that we can fail. So we could possibly choose all 8 out of that 16. So the smallest possible value of x here, which is again the number of successes, is 0. And then of course the max could be 4, right? We couldn't go beyond 4, right? So let's use our sequence function to define those possible values of x. Now again, that might be a little overkill because that's only 5 values, but either way, we can still use our function. So we can get practice with using this. So sequence, and we want 5 rows, right? Because we're going from 0 to 4. So we want 5 rows. They're all in one column. They start at a value of 0 and they end at a value of 4, right? And well, not end at a value of 4. We need to put the step size there. A step size is 1, right? So it's going to generate 5 rows of values starting with the smallest value of 0 and then incrementing with a step size of 1. So there we go. So those are the possible values of x for this hypergeometric distribution. Now for the PDF. So we're going to click on the cell that corresponds to the smallest possible value of x, and we're going to use the built-in Excel function to put our PDF values here in column B, right? So we're going to go up to our formula bar and start our function with the equal sign, just telling Excel to get ready to do some calculation. And the function for the hypergeometric distribution, it's hyp hype geom, Geom, and then period dist distribution, right? So you can see the abbreviations there. And then now it's asking for a lot of stuff, right? So the sample successes, that's our possible values of x, right? And we want it to go ahead and compute all the probabilities for each of the possible values of x. So we're going to tell Excel to look in cells A3 through A7. So A3 colon A7. That's how you define a range in Excel. And what's nice is it highlights the range, so you can see exactly what that you are referring to the correct values. Next up, the number in the sample. Well, that's our little n. So the little n in this case is 8, right? So put an 8 there. Population S, that means the number of elements in your population that represents a success. Well, for us, that's 4. That's our little a. And then the number in your population, so that's your big N, here it's 20, right? So it's important for you to realize that the way Excel defines it, or the notation that Excel would use, their order is little n, little a, and then big N, whereas our order is big N, little a, right? But as long as you are aware of that, and that's why it's nice that you can see Excel tells you what input goes in what position, right? So we just completed our big N, and then we have that fifth option for do we want the cumulative or do we want the exact? So do we want PDF or CDF? Well, we want the PDF values. So we tell Excel no. And the way we do that is by using the binary number 0. So we say 0, you can think of it as true or false. When it's 0, it's not going to give us the cumulative values. It's going to give us the exact values. Close the parentheses, hit enter, and there are the exact PDF probabilities for this hypergeometric distribution. So for instance, I could look at this and say the probability that we will get exactly 2 successes, that's the 0.381424149, right? Or the probability that we will get all 4 successes, right? And that would be your 0.014447884. And we can't get any more successes. So even though we're sampling 8 out of this population, because the number of ways of choosing a success or getting a success is so small, then it limits this, right? Now let's do the CDF. It's the same process, right? We are going to have to go up to our formula bar equals, and then our hypgeom period dist number of samples. Again, that's from A3 to A7. And there it is, all highlighted for us. The number in the sample, number in sample, that's our little n, so that's 8. The population S, meaning population successes, that's 4. And then the number in the entire population, that's our big N, so that's 20 in this example. And now we do want it cumulative, so instead of putting a 0, we put a 1. And close the parentheses, hit enter, and there you go. And you can see this is what we expect, right? This is what we expect from the CDF of a finite discrete random variable. You can see it accumulating all the probabilities, and then that largest possible value of x, that's where all the probability has been accumulated. So now, for instance, if I wanted to know what's the probability that we will have less than or equal to 2 successes in this sample, then that would be the probability 0.8468525, right? If I wanted to know the probability that x is less than or equal to 1, well, that would be that probability, 0.465428277, right? So there is our hypergeometric distribution in Excel. Pretty straightforward. We just have to make sure, though, if we are creating our complete table, that we make sure that we compute the possible range of x, right? The possible x values based on that formula that uses the min and max functions, right? But Excel can go through and compute the tedious number crunching for us, right? All right, hopefully you found that informative and helpful. Let me know if you have any questions. See you.